Hey, hello everybody, it's Damon, Crazy Logics 007 on YouTube and Crazy Logics in the forum. Uh, this will be Skar video number 3 on the big 4500. We had a little crazy oops in the last video, and if you don't know what I'm talking about, go watch the Skar 4500 video number 2, and you'll about midway through we'll be talking about what's happening, and then you'll see it towards the end there. Uh, I'm still moving, getting ready to pack this bench up. Actually, right now there'll be some more stuff. Hopefully, a video about moving into my new garage area and setting it up. We'll see what we can do. Still working on my truck, all kinds of stuff. But I want to do a little giveaway. We'll give it. We'll finalize it in a few weeks when I get another few videos up. But I have a reproduction Rockford Fosgate Punch 45 HD label. Goes on the amp to replace torn up ones and stuff. These were reproduced from the original, and I sent copies and stuff to Rockford Fosgate because Rockford Fosgate no longer offers this. So you have to make your own. And so as long as I'm not trying to say that these are original, and I'm not, raping people with money kind of thing, like I said, it's reproduction, and they're cool with me making some so that everybody can fix up their amps when they've had them all scraped up and tore up. You can clean it all up, refinish it, get you a new label on there, and then it looks good whether you want it to hang on your wall or whether you want to use it. But anyway, to qualify to get this label for the giveaway, I'm going to mail it to somebody. Two things. One, you got to be a subscriber. That'll help me out. Isn't that always the case? Two, comment down below the time in the video where I admit that we had an error with the via, and you can get close as long as you're within about 5 seconds or so of that area. It'll count. Like I said, be a subscriber, and then I'll let the video run for a few weeks, and we'll get a whole bunch of people hopefully commented down there. Comment other stuff if you want to with it, and then we'll do a little random number generator and give this away, and I will send it to one lucky viewer. So I appreciate it. I appreciate you guys' patience with my move and everything and all the remodeling and stuff. It's been a really crazy time for me. But here is Skar video number 3, and hope you learned something, and hope you enjoy, and hope it inspires you to try fixing something, or take your old amps and at least send them off and get them fixed. If it seems overwhelming to you, at least you know what's involved in this kind of stuff. So, all right, thanks again. Once you get it wiggly, they're all broke free. Just give it a wiggle back and forth. You'll see. I'll make sure all you gotta look at it the right way to make sure all the legs are moving. Once they're all moving right, you can put a tiny bit of pressure going down, and normally they'll just slip right on out. We're wanting the vias to stay intact. So just give it a poop. And then, if I can, I'll bring it down here. There we go. And you'll see that every leg came out perfect with no torn up vias. We left all of them in the circuit board. And the vias are the plated through holes. So now, that's all perfect. Come back and get a little dab of flux. Ooh, my flux is dirty. Oh, let's grab a towel and, oh no, pulled out my needle. Just can't win for losing no matter what. Got junk all over my hands. Get a little flux here. We want a little extra. Just to go with a little bit of clean desolder and kind of get that in there. This got rosin flux in it, but man, a little dab goes a long way to helping now that those are free and clear. No, I think that's... Bam. Just real gentle like. Make sure it's good and flat. That little extra flux will help suck that all right up. And shazam, we got it out. So I'm gonna... Here we go, magic of swapping around the mics and stuff, and we'll get to this driver board now that we're cleaned up here and good to go. Transition. Okay, welcome back real quick. So we're going to inspect this board, and one of the things we want to check is these diodes right here. There's 4 of them. We want to get a diode reading in one direction and nothing in the other. That's good. That's good. We want nothing in this way. We want nothing in this way. Just get a diode reading in this direction. Same there. And then we want to check these caps. Make sure that they don't say shorted and they don't beep. And then we want to check this little transistor for shorts. And if those are all good, then you can get your inspection loop out. Mine's dirty as all get out, and cracked and dying, and take it out and give it a real good look and make sure there's no discolored resistors along the top here. I'll show you those, all those resistors there along the top, and any of these components in the middle. Normally if something dies, it's this little transistor up here. Every now and then you get something in here, but that's pretty rare, and you'll if it bakes anything in there or any of these, then you start looking for more trouble. But I mean, I think we got awesomely lucky with this one. I just look at every component and they all look really good. So we're going to set this up right there. So to remove these, I'm going to use my hot air, but because that's done with leaded solder, we're going to get the, with lead-free solder, sorry, we're going to get the soldering iron, the little soldering iron out. Get my glasses so I can see. And what I do, I'm actually going to turn this so you can see, maybe, just like that. There we go. I'm going to get solder on the end. I'm going to add solder. I don't care if I bridge. But what I'm wanting to do is mix with that lead-free solder on those legs, and we are effectively lowering the melting point, so it'll take less hot air to remove these. And so everything I've learned to do about surface mount has become 1,000 times easier thanks to sites like Lewis Rossman, Jessa Jones, she's from iPad Rehab. They do micro soldering all the time, little stuff, and so they got all these little tips and tricks of always add solder to all their stuff they're going to hot air rework and do. So now I've added solder to that. We should be able to grab some tweezers and get the hot air out. There was a bug in the end of my hot air rework. Phew, that stinks. He's a cooked bug now. Because now, technically, when we're going to do some general heating of the board, and we can start focusing in on the middle, but we want to gently heat it. We don't want too much heat in one spot to start out with. We want that board to, you know, thermally expand a little bit. Then we can come in here and start focusing hard. Oh, and I've got my settings a little low Maybe a little higher there on the heat. In here, like I said, I'll keep spreading that heat out a little bit because we don't want to warp or damage the board. But you'll see some of that solder start to go. And we did slightly move that cap and this one. That's why the lead-free solder is hopefully that you'll melt the chip off before. There we go. Get a hold of the chip. I'm going to generally heat this thing up. I can focus down on the chip. A little general heating some more. Normally once you get one done from this side, the other one goes pretty quick too because of your general heating. We just don't want to singe any part of the board. And this takes practice. You get better at it the more you do it. And that lifts off. And you get focused on there. Like I said, the whole point of it is so that we don't end up too much. I'm going to see if I can get that capacitor just back perfect. Alright, and this is a silicone mat, by the way. $10 on Amazon. So we got those chips off. Yeah, there it is. So, get our nippers. Now we're going to come back. Suck up the big blobs first. Just keep nipping that off. Get the big majority of it off. These big blobs off here. So all we're left is with a little bit to worry about. Alright. Once the majority is off there, let's get these chips out of the way. And I'm going to talk to you about these chips while I'm doing this, but we're going to get a little bit of flux. There's already flux some down there. You can see the shininess. A little dab, just a little dab. I don't need much because there's flux on the stuff. This just really helps it. I really like using flux. You can never use enough flux. Says Louis Rossman. He uses a Paul amount. That's his measurement system. Soldering iron out here. Okay. So now I can take this. I can gently go across here. Do not tug on your stuff if it's stuck because you took your soldering iron away or something slipped. Get your soldering iron back on it. Because you do not want to pull these gentle little traces. That would be bad. See, I pulled away before it would slide. Now, I always keep nipping this off so I don't end up trying to heat up too much desoldering braid. So it does a good job. I'm just going to clean this up. There we go. That's nice. Get hot and flowing, and then just take it across there real nice and slow and gentle, very gentle. It's like a Bob Ross kind of thing, a happy little gentle little something, I don't know, but Excellent. We need to get a little bit of isopropyl alcohol. Clean up our old flux here. From where we've removed those. This is actually the acetone, not the isopropyl alcohol. So bam, that is all cleaned up. So big thing, these are the chips, and they come in a sealed bag, and see that they say caution, moisture sensitive devices, and it gives you a level, tells you when it's good and needs to be mounted within 1 year. Inside that package is this. There'll be a humidity indicator and a pack of the silicon dioxide, or whatever the heck it's called, the stuff they tell you don't eat. That absorbs moisture. And so if this is if it's perfect in this bag, all of these will be blue, and that tells you a level 2A to 5A part. These need to be blue, so you need them to use them really fast. Well, this isn't that much of a moisture sensitive. This one needs to be blue. It's just a level 2 part. So if that turns pink or white and is not blue, these parts need to be carefully baked, and there's a procedure to do that. So you kind of use them up before they go, before you get to that point. But the reason why they're so worried about this, I don't know, the overhead light's making that look like that's white. Oh, you can see it there, kind of, or you can see it there. That's still good and blue. So the reason why is because when these boards are manufactured, they have a raw board, they put a mask down, and they scrape solder paste. It's a leaded solder paste, and then when they lift the mask off, it leaves little bits of solder right on each one of the pads. And then a pick and place machine will set all these components on, and then it goes into an oven and gets baked on there at high enough heat to melt the solder and get it to all flow. That temperature is high enough that if there's enough moisture in here, some of the little bitty tiny connections and stuff, that moisture can like steam up, because you're over 212 degrees, which is Fahrenheit, or 100 degrees Celsius, which is the boiling point of water. So the moisture that has got into those chips can turn to steam, and some of the interconnections onto these chips, because these are little microcontrollers almost, they're really smart little chips. It can damage the delicate internal structure. And so that's why they have to be under a certain amount of moisture. So when you do rework though by hand, technically if you do it the way I do it. Oh, and I forgot to point out, when we had these all and we were removing them, there is a little tiny dot in the corner, and that tells you which leg is pin 1. And it happens to be where this little tool, maybe I better get this up here where you can see it. See if that'll focus. See the little arrow right, I'm upside down, so see it right there? That points to number 1, so that little dot would go in the upper corner of all of them. So my new chip is going to have a dot. I may have to get my glasses out to see it. Yep. So I will put it down here in place, and this is how I install them. I'm going to see if I can get you. I'm not sure how well the zoom in cam is going to work, but we'll leave it to both of them. So I'll put the chip down and get my soldering iron, and I'll put a little dab of solder on my soldering iron, and I'll get the chip lined up exactly where it's supposed to go and hold it in place with the tweezers really nice, and I'll touch just that number 1 leg just enough to give it a little solder. Put a little dab of solder back on again, hold the chip down and pick another leg, like we'll take this one and just get a little solder on it. And so now notice that chip won't move, and so it's in place really nice. Let's touch this one again and touch that and make sure it's on there. Yep. So here's my secret. Flux. You can actually clean that end off a little here. Instead of trying to float that sucker on there and blow it with hot air and redo it, and that hot air is what would cause the internal damage if the moisture was too high. We're not going to heat the middle of this chip at all. We don't want to. We want to put a little flux. And there's a dirty bug that came out the end of there. Oh, the bugs are bad. It's summer, and they are out in full force. And we're going to put a little flux over here. And what that flux does is it helps wet that solder only to where the solder needs to go. It'll keep you from making bridges. Make sure we get plenty on there. Can you? I bet you I didn't have that focused for crap. This thing's trying to focus too much on me and not enough on the part here. Aha, let's do it that way. So I've added solder, or sorry, not solder. I've added flux down each row. And now I'm going to take a soldering iron and I get a little bit of solder. We're going to go on the side that I did not solder the first time, so that those legs are still going to help hold it. And I'm just going to touch and flow, and that flux will keep us from forming solder bridges. And I'm going to go across the legs and the pads, and it's just going to do it. I'm going to let that side cool and you'll be able to see it from this side. Add a little more solder. If I start to run out, I add a little tiny drop more. And what we've just done, see how it soldered all those legs perfectly, is solder that up without getting that whole chip super hot. We only did the legs and the pads. Did it so quick, and the flux allowed us to not have a single solder bridge, and it installs perfectly. And so I'm going to do all the rest of the chips, and then I will clean them up just like normal with a little isopropyl alcohol. But by doing that little install that way, I reduce the amount of potential damage if there was a little bit of moisture in these. And even though I got a good blue dot, I ain't even gonna risk it. I know that by installing it this way, I didn't even get anywhere close to its potential for damaging that in there, because I did not get that whole stinking chip hot. And so when I put all these chips in, bam, they're all going to be fine. I know I didn't damage any of them, and we'll be ready to reinstall this. And now I know it should be 100% good. Whereas, like I said, that moisture setup is for a factory when it's in a bake oven to melt all the solder paste. So when you see, this might be the end of the video, I don't know. There's going to be a whole bunch of editing, but I'm trying to get this thing done. Because I am moving, and it's getting closer and closer every day, and we got more and more to do. So I'm going to finish these up, and then you should see me, I may even have this soldered back into the board when we flip it, and we'll start powering up and doing some tests and checking for square waves and stuff. So another transition, or maybe in the next video, I'll put something. Always. So I forgot to mention one thing that's real important. I got all these in and I went to clean them. I only clean these moisture sensitive chips with not isopropyl alcohol, but acetone. Only acetone, because the isopropyl alcohol has water in it, and so we don't want to add to their already moisture phobia. So acetone only. Okay, so we fixed the driver card, and we need to apply power, so I've hooked up power, but First, I need to go to the optometrist because on this here driver board, after I'd got all these soldered in and everything and turned off the recording, I whipped out my little magnifier to go over and make sure all my legs were perfect and everything. And I noticed on this leg right here, I don't know if I can get that to focus right. This look right here, there was a via, and I went to touch it and it went flick and it came right off and I lost it in the floor. So I don't know where it's at, but it doesn't really matter, and I'll kind of show you why. So like I said, I need to go get my eyes checked a little better. Let me move my stuff out here and we're going to get the little cam. So when you pull a via, that's why you inspect it, and I don't know why I missed that one and it flicked right off, so it wasn't really held on by anything. But you need to, let's go to where we can get zoomed in here. Okay, now let me have my pointer. So we pulled this via right here. Okay, you can see that there's no longer silver. All the rest of them have silver. So when you pull a via, that's bad because the vias connect the top of the board to the bottom of the board with a conductive path. And it's really important on stuff like this one, where, see, it's going to be a connection from the bottom of the board to the top of the board, kind of thing. Now, as you noticed, the one that pulled has no connection here on the top of the board. As a matter of fact, it's just a connection on the bottom of the board right here to this. So when we solder this all back in, we can put our multimeter from here to that pin and make sure there's good connection. And there's going to be. I looked at the trace on the back side of this when I discovered that the via had got pulled. So what I have found when this happens is the vias that pull, because you're going to be pulling from there. They're going to pull out from the direction you pull out, and the ones that don't have anything they're connected to on the top, where they've just plated all those vias because that board's getting soldered in there, those are the ones that like to slip out the easiest because they don't have any extra trace to help hold that via in place. They're just kind of pressed there, and so those are the easiest ones to always pop out. The whole bottom of these things, there's a solder pad on the bottom of every one of these. So normally if you pull one, as long as you took your time like we did and everything, it's going to be whichever one is weak or whatever, and it will almost 99% be one that does not have no connection on the top, and that's why it pulled so easy. Had it been one of these ones that does have a connection, we'd have to get a replacement via. We might have to drill the board out just a tiny bit, stick it in, press it, and solder it to the surrounding trace that it needs to connect to from the top and bottom, and then you would just install it and resolder it. You double check it with your meter to make sure everything was good. But since it happened to be on a pin that's not used, and it's right there off that inductor, which is going to be providing power up onto there, we can test that after we get it soldered in and make sure it made a good connection, but it will. So like I said, I need to get my eyes checked, but for having one via pull out of there, that's somewhat to be expected. After you've pulled so many boards, you're going to get one or two of these, and it just happens. And thankfully it's the ones that aren't connected, and that's why we took so much time to get it wiggled free, so that these really critical vias that do connect the top and bottom of the board are still there. So got it ready to power up. We've got our little, oh, you can't see it. I need to tilt just a little more. I'm just hoping to catch this. I'll put my hand down by it so that maybe you can see the glow. We're going to turn on the power supply. Now we don't have any FETs in it, no output FETs. We don't have the driver board in. All we're going to do is, oh, sorry, you can't see. All we're going to do is verify the voltages coming off the power supply are good. And then we need to check these. These are the 12 volt regulators. These are the 15 volt regulators. And then right down in here is, on this amp, are the little 5-volt regulators, and that provides all the voltages for the opt amps and for all the driver circuit here. So it's pretty easy to do. We should have the low side in the middle here and the high sides out here. You can reference it off the RCA ground. The 15-volt regulators, we can reference the ground to here and look at those for 15 volt. Same on the 5-volt regulators. However, these 12-volt regulators right here, they are from reference from the low side. So we need to reference them from the low side's negative to see that correctly. So we just want to make sure we got the appropriate voltages. So the first thing we're going to look for, and you can see the voltage here, I've got it set on 200, and we got residual less than a volt coming off the rail caps here. So this amp does bleed off very well. Gets down to a volt, and it's hard to get every single volt off of these. Eventually it will, but that last little bit takes forever. So we're going to put our meter on there, and I'm going to, let's see if you should be able to see the glow on my finger here. There's the red, and there's the green. You can see it on my finger, and we are building positive rail voltage here. Looks like about 130 volt. Let's go over and look at the low side. It's building 130, so we're going to end up pretty good. So off this same one, I need to look at there's my 14.8 volts. There's my negative 15. I have to put my glasses on here. I definitely need them, don't I? Oh, that's the wrong one. It's going to be the inner. You're going to be super careful. There's my 5 volts, 4.8, 4.9. Negative 4.8, 4.9. And now I need to go off the negative rail voltage. And there should be my 11.8. And I should have another one that's 11.8. Very, very good. We'll shut it off. Oh, let's watch this rail voltage. Let's go ahead and power it back up for one more second. Feel these for make sure they're not getting warm. Shouldn't be. Whoa, that's not good. Don't want that to fall off there. Bugs. So we are at 134. We'll call it 130. We'll call it 135. That's about what's peaking now. It won't be that once FETs are installed. It'll drop down to maybe 130 or maybe a little less. But the point I want to make, and we're going to watch this. We want to watch this. Is that you've got positive 135 volts and negative 135 volts. Add that up together. That's 270 volt potential between the positive and negative rail. And that will zap you. That'll zap you good. So this amp does have bleed off resistors, and so it is slowly dropping down, and we're just going to let it drop all the way down, and we'll check it before it does. I'm going to kill the power, and once it's dropped, then we'll go ahead and move on to the next step.